Hello guys, I'm Karthik SP from SPC and today my topic is Introduction to Image Processing CGIPL subject. So let's start. So Introduction to Image Processing. Image processing is a fascinating field at the intersecting of computer science, mathematics and engineering dedicated to analysis and manipulating digital images. It involves the extraction of meaningful information from images or altering them for various purposes. Here is a brief introduction to the key concepts and processes. Introduction to the image processing. Digital image. In image processing, an image is represented as a two-dimensional array of numerical values, where each value corresponds to a pixel intensity or colors. These pixels are the smallest units of informations. Information from images are altering from various purposes. Here is a brief introduction to the key concepts and processes. Digital images in image processing, an image is represented as a two-dimensional array of numerical values, where each value corresponds to a pixel intensity or color. These pixels are smallest units of information in an image. Image acquisitions. Image can be obtained from various sources, such as digital cameras, scanners, satellites, or simulated using computer graphic techniques. Image representations. Images can be represented in different colors, spaces such as RGB, grayscale, CMYK, such as cyan, magenta, yellow, as well as black, depending upon the application requirements. Image enhancement. This involves improving the visual appearance of an image by adjusting contrast, brightness, sharpness, or reducing noise to make it more suitable for analysis or display. Image restoration. It deals with the process of improving the quality of an image by removing artifacts, blurs, or distortions caused by the image system or environmental factors. Image compressions. To efficiently store or transmit images, compression techniques are used to reduce the amount of data required to present them with while preserving essential information. Image segmentation. This process divides an image into multiple regions or segments based on certain characteristics such as color, intensity, texture, or motions. It is a crucial step in object detection and recognition task. Image processing encompasses a wide range of techniques and methodology aimed at manipulating the digital images to extract useful information, enhance visual quality, or performing various analysis tasks. Here's a concise overview of the field. Digital image fundamentals. Image processing begins with the acquisitions of digital images. Displays represents as a two-dimensional grid of pixels. Each pixel carries information about color in RGB or other color spaces or intensity in grayscale. Understanding these fundamentals is crucial for subsequent processing tips. Image enhancement. Enhancement techniques aim to improve the visual quality of image for human perception or subsequent analysis. This may involve adjusting contrast, brightness, as well as sharpness. These image enhancement techniques aim to improve the visual quality of digital images by adjusting their appearance to make them more suitable for human perceptions or analysis. These techniques can enhance various aspects of images such as contrast, brightness, sharpness, and overall visual clarity. These are some common image enhancement techniques. Histogram equalizations is a method used to improve contrast in images by redistributing pixel intensities. Works by stretching the histogram of pixels intensities to cover the entire dynamic range, resulting in a more distributed histograms and enhanced contrast. Contrast stretching, also known as a normalization, involves stretching the range of pixels intensities in an image to span the entire available dynamic range. This technique enhances the contrast between different range of the images, making it usually more appealing and easier to analyze. Brightness adjustment. Brightness adjustment technique alters the overall brightness level of an image to make it bigger or darker. Image processing holds immense importance in today's digital world and finds application across numerous fields. Here is a closer look at its significance and some of its key applications. Image processing is in the field of medicine techniques like X-ray, imaging, MRI, magnetoresonance imaging, CT, tomography, ultrasound and PET, positron emission tomography. Scans heavily rely on image processing for diagnosis and as well as treatment, planning and monitoring of various medical conditions. Biometrics image processing plays a vital role in biometric systems for recognizing individuals based on their physical or behavioral characteristics. Facial recognition, fingerprint identification, iris scanning, and hand geometry are the examples of biometric modalities. Extensively used image processing algorithms. Satellite imaging and remote sensing image processing is essentially for analyzing and interpreting satellite imagery and remote sensing data. It adds in environmental monitoring, disaster management, urban planning, agriculture, forestry, and natural resource management. Robotics and automations. In robotics and automations, image processing enables robots and autonomous systems to perceive and interact with their environment. Application include objects. Security and surveillance. Image processing is crucial in security and surveillance system for monitoring, detecting, and identifying potential threats or suspicious activities. Includes tasks such as face recognition, license plate recognitions, crowd analysis, and anomaly detections. Entertainment and multimedia. Image processing techniques are intensively used in the entertainment industry for creating visual effects in movies, video games, virtual reality (VR), and augmented reality (AR). This includes techniques like image compositing, background removal, motion capture, and 3D modeling. Forensic and law enforcement. Image processing aids forensic experts and law enforcement agencies in analyzing digital images and videos as evidence in criminal investigations. Includes tasks such as image enhancement, forensic image comparison, and tamper detections. In industrial inspections and quality control. In manufacturing and industrial settings, image processing is used for inspecting products, detecting defects, and ensuring quality control. Helps automate inspection processing, reducing errors and improving efficiency. Astronomy and astrophysics. Image processing is indispensable like astronomy and astrophysics for analyzing and enhancing astronomical images captured by telescopes and space probes. It facilitates tasks like image tracking, noise reduction, and image detection in astronomical data. Education and research image processing serves as a valuable tool in education and research, enabling students and researchers to study and analyze various phenomena captured in images and videos. It contributes to fields such as computer vision, machine learning, and artificial intelligence. Image processing is a field of study and practices that involves analyzing, manipulating, and interpreting digital images using computer algorithms and techniques. Encompasses a wide range of methods aimed at extracting useful information from images, enhancing their visual quality, or performing various analysis tasks. As its core, image processing deals with acquisition, representation, and manipulation of digital images. Here is a breakdown of the basic components. Acquisition: digital images are obtained from various sources such as digital cameras, scanners, satellites, medical image devices, or simulated through computer graphics. These images are represented as an array of numerical values with each value corresponding to the intensity or pixel of color of a pixel. Representations: images are typically represented in two-dimensional grid, where each pixel position corresponds to its local in the image as its value represents its color or intensity. Color images may use different color models such as RGB, red, green, blue, grayscale, CMYK. Manipulations, image processing techniques manipulate digital images to achieve various objectives. This may involve enhancing the visual quality of images by adjusting contrast, brightness, or sharpness, removing noise or artifacts, or altering the image appearance, the artistic or practical purposes. Analysis, image processing also involves analyzing images to extract meaningful information or perform specific tasks. This includes tasks such as segmentation, dividing an image into distinct regions and features. Image processing involves several steps, each serving in a specific purpose in analyzing, enhancing, or manipulating digital images. Here are the fundamental steps typically involving in image processing. Image acquisitions. The process starts with acquiring digital images from various sources such as digital cameras, scanners, satellites, or medical image devices. The quality and characteristics of the acquired influences subsequent processing steps. Pre-processing involves initial operations to prepare the raw image data for further analysis. This may include tasks such as resizing, cropping, color space conversions, and noise reduction to improve the quality of these images and make them suitable for subsequent processing. Image enhancement techniques are aimed to improve the visual quality of images by adjusting their appearance to make them more suitable for human perception or analysis common. Image restorations. Restoration techniques focus on removing distortions, blurs, or other imperfections introducing during image acquisitions or transmissions. These methods aim to recover the original undistorted images by modeling and compensating for various sources of degradation such as motion, blur, noise, or atmospheric interference. Image compressions techniques reduce the size of image data to save storage space or transmissions bandwidth while preserving essential information. Compression set can be lossless while the original image can be perfectly reconstructed or loosey, where some data is discarded to achieve high compression ratios or cost of reduced image quality. Image segmentation divides an image into meaningful regions or segment based on similarity in color, intensity, texture, or other visual attributes. Is a crucial step in object detection, recognition, and analysis tasks, enabling the identification of objects or regions of interest within an image. Feature extractions. Feature extractions involves identifying and quantifying distinctive patterns or structures within images. These features, such as edges, corners, textures, or shapes, serves as the basis for high-level image analysis tasks like object recognition, classification, or tracking. Pattern recognition focus on identifying and categorizing objects or pattern within images based on their visual characteristics. Encompasses techniques from statistical analysis, machine learning, artificial intelligence to automate the process of image interpretation and decision making. Image analysis involves interpretation and extracting useful information from images to derive insights or informs decision that may include like tasks such as object detections. Gamma corrections. Gamma corrections is a non-linear adjustment applied to image pixels to compensate for the non-linear response for digital devices. It involves raising the pixel values to power functions with gamma value, which adjust the brightness level to better match human perceptions. Spatial filtering. Spatial filtering technique applies filter or kernels to image pixels to enhance specific features or remove noise. Common spatial features include smoothing filters. Histogram matching. Histogram matching, also known as histogram specifications, involves modifying the histogram of an image to match a specific target histogram. This technique is useful for adjusting the tonal distribution of an image to match a reference image or a desired distributions. Adaptive enhancement. Enhancement technique adjusts the image enhancement parameters locally based on the characteristics of image regions. These methods adaptively enhances different regions of the image according to the contrast, brightness, or local properties, resulting in more tailored enhancement. Dynamic range compressions. Dynamic range compressions technique compresses the dynamic range of an image to improve its visibility in both dark and bright areas. This can be achieved using techniques such as tone mapping, which maps the original pixel values to the narrower dynamic range while preserving overall contrast and detail. Color enhancement. Color enhancement technique modifies the color distribution of an image to improve its visual appearance or emphasize certain colors. This can be include methods such as color balance, adjustment, color saturation, enhancement, or selective color enhancement to highlight specific hues. Image restoration method aim to recover the original undistorted image for the degraded or imperfection version caused by factors such as noise, blurring, comparison, artifacts, or other famous forms of distortion. These methods typically involves modeling the degradation process and happily appropriate algorithms to restore the image to its original quality. Here are some common image restoration methods. Total restoration, image restoration methods, total variation regularization. Total variation IV regularization is a technique commonly used for image denoising and blurring. It exploits the spatial disparity of image gradients to improve smoothness to the restored image while preserving edges and fine details. TV regularization is often combined with optimization algorithms such as gradient descent or proximal methods. Non-local means NLM. The non-local means algorithm is a powerful denoising method that exploits similarities between images patches to remove noise while preserving the image structures. It computes a weighted average of pixel values in a neighborhood based on the similarity of image patches, effectively reducing noise without blurring edges or textures. Sparse representation based restoration. Sparse representation based restoration method models the image as a linear combination of a small number of basis functions or atoms set from a learned dictionary by promoting parity in the representation coefficients. These models can effectively denoise, deblur, or enhance images with structured noise or sparse artifacts. Deep learning based restoration. Deep learning approach, particularly convolutions neural network (CNN), have shown remarkable success in various image restoration tasks, such as denoising, deep learning, super resolutions, and implementing these methods lean end-to-end mapping from decreased image to the corresponding clean versions using large data sets and powerful neural network architectures. Wavelet-based restorations are commonly used for resolutions analysis and signal denoising. Wavelet-based restoration methods decompose the image into different frequently based applying denoising or restoration techniques at each scale. Image segmentation. Image segmentation is a process of partitioning of a digital image into multiple segments or regions based on certain characteristics, such as color, intensity, texture, or motion. The goal of segmentation is to simplify the representation of an image by grouping together pixels they belong to the same object or regional while separating them from pixels belonging to the other objects or backgrounds. Here is an overview of the key concepts and methods in image segmentations. Thresholding. Thresholding is a simple segmentation technique that separates objects from the background based on the specific thresholds. Value pixels with intensities above the thresholds are classified as foreground, with below the thresholds are classified as background. Thresholding is effective for images with clarity, with clear intensity differences between the objects and background. Edge space segmentations. Edge space segmentation methods detects edges or boundaries between different objects in an image and uses them to delineate the regions. Common edge detection techniques include the Sobel operator, canny edge detector, and prefit operators. Once edges are detected, region growing or edge linking algorithm can be used in order to connect adjacent edges and form closed boundaries around objects. Next is region-based segmentation. A region-based segmentation technique partitions an image into regions based on similarity, criteria such as color, texture, or intensity, homogeneity. One popular method is the region growing algorithm, which starts with seed points and iteratively merges neighboring pixels or regions that are similar according to predefined criteria. Next one is clustering. Clustering algorithms such as K-means algorithm and Gaussian mixture models are often used for segmentations. This method pixels into clusters based on the similarity in feature space, where features can include the colors, while textures, descriptors, or pixel intensities for cluster represents segmentations or regions into the image. Watershed transforms. The watershed transforms is a powerful technique for image segmentations based on the concept of watershed lines, which represent boundaries between adjacent catchment basins. Graph-based segmentation method represents an image as a graph, where nodes corresponds to pixels or image regions, and edges represents pairwise relationships such as similarity or proximity. Segmentation is achieved by partitioning the graph into disjoint sets of nodes using graph partitioning algorithm. Deep learning based algorithm segmentations. Deep learning technique, particularly convolution neural network, have shown remarkable success in image segmentation tasks. Fully convolution networks such as architects are commonly used for semantic segmentations, where each pixel is assigned as a class label corresponding to the object or region to where it belongs. Feature extractions is a fundamental step in image processing and computer vision that involves identifying and quantifying distinctive patterns or structures within images. These features serve as a concise representations or underlying image contents and are used for various purposes such as object recognition, classifications, matching, and analysis. Here's an overview of it in image processing. Feature extractions. Edges are observed changes in pixel intensities and represent boundaries, whereas corners are points where the intensity gradient has the significant changes in multiple directions, making them useful for image restrictions, tracking, and 3D reconstructions. Texture refers to the spatial arrangement of pixel intensities in an image and provides information about surface properties such as smoothness, roughness, as well as regularity. Descriptors are a compact representation of local images, patches, or regions and encode information about their appearances, shape, and textures. Color features quantifying the distribution of color values in an image and are useful for tasks such as image retrieval, segmentation, and classifications. Medical imaging. In medical imaging, image processing is extensively used for tasks such as diagnostic images, image-guided surgeries, tumor detection, tissue segmentation, and disease classifications. Feature extraction also includes surveillance and security, remote sensing, robotics, and anatomic systems. So real-world applications such as there are image processing. Image processing is extensively used for tasks such as diagnosing X-rays, CT scans, as well as MRIs. Retail as well as e-commerce. Image processing is utilized in retail e-commerce applications for tasks such as product recognition, object tracking, image search, and visual recommendation systems. Hands-on examples. So next is the basic of image processing. It mainly include image acquisitions, image representation, image enhancement, image restorations, as well as image compressions, feature extraction, pattern recognitions. Later is the application of image processing. It involves medicines, remote sensing, as well as robotics and automations, entertainment as well as media. Biometric as well as forensics are involved, industrial inspections, agriculture, retail, and e-commerce. So here are some key components such as images are represented as an array of numerical values and values corresponding to their intensity or colors. The pixels, these are the smallest unit of information in an image. Importance of image processing and its applications involved mainly image acquisitions, image enhancement, restoration, compression, segmentation, extraction, as well as pattern recognitions. Modalities of medical imaging. Computed tomography such as CTs use X-rays and computer processing to generate cross-sectional images of the body. MRI uses strong magnetic fields and radiomagnetic fields to produce detailed image of the body, soft tissues, organs and structures. Ultrasound imaging, also known as sonography, uses high-frequency sound waves to create real-time images of the internal body structures. Modalities of medical imaging. Nuclear medical imaging technique involves administering radioactive substances to patients using specialized cameras to detect the immediate radiations. Application of medic modalities include biometric satellite imaging and remote sensing. Image segmentation includes thresholding. Is a simple yet effective segmentation technique. Threshold selection chooses an appropriate threshold value based on their domain knowledge, histogram analysis, or automated methods such as UTSU method. Threshold operations, if the pixel intensity is above the thresholds, assigns if the foreground images. Region-based segmentations. Uh, Regions growing algorithms iteratively group neighboring pixels into region based on similarity criteria. Feature extraction includes scanning edge detector, zero crossing detector. So corner detection is a technique used to identify keypoints or interest points in an image that represents corners or junctions between different image features. So conclusion part, image processing overview is manipulating digital images in order to enhance their quality, extract useful information, or perform analyzing tasks. Image enhancement techniques like histogram equalization, contrast adjustments, and noise reduction improve the visual quality of images by enhancing contrast, reducing noise, and sharpening details. Deblurring techniques and image denoting methods used to remove blur and noise from images, restoring the original clarity and fidelity. Segmentation partitions an image into meaningful regions or object based on similarities in the pixel intensities, color textures, or motions. This is further reading, such as online resources are useful thing. So this is the end of this slide. Thank you. Have a nice day. Bye.